Hello everybody. Today I'm going to prove this triple product which is called a scalar, because we have a scalar triple product, and I'm going to show or prove that uh, A dot B cross C equals A cross B dot C, and I'm going to also solve an example and show it in example, show this relation. Okay, so if you have watched my previous tutorial, I gave a very useful equation which I'm going to rewrite it again here, and that is B cross C, the ith component, equals, or for example if I is 1, then first component, or I can be 2 second component, or I can be 3 and then third component, like this is third component of A, or this is first component of A. Okay, so this equals epsilon I j k b j c k, and I'm going to use a convention. When two indices like j and k are repeated, that means a summation. This is Einstein's convention, so it means we have epsilon sigma j sigma k, then epsilon I j k b j c k. So this equals this guy actually. So this convention, I repeat, if j is repeated, or k, we have two k's here, that means there is a summation on k. But I is alone, that means there is no summation on I. So please remember this, and you will see this summation convention kind of almost everywhere. Okay. And I also know if I dot A by another guy, let's say B cross C, that means AI with summation on I, B cross CI. So summation is on I because we have 2I here. It is repeated, so it's like we have summation over I. So now I'm going to use this, substitute this guy here. So therefore this guy equals AI epsilon I j k b j c k. As I mentioned in the previous tutorial, this is Levi-Civita symbol, and it can take only 1, 0 and -1. And let me repeat this one more for one more time. So if two of the indices of this epsilon repeat, so if we have two same indices like 1 and 1 and something else here like 2, that would be 0. Or if, for example, I have 1 2 2, then that is also 0. Or if I have epsilon 3 1 3 or 2 3, then they are all 0. So whenever we have two same components or indices, this epsilon is 0. If they are not the same, then if I write 1 2 3, and for example I have 1 3 2, and I start from here, go to 3, so go to 3 and 3 to 2, and this is counterclockwise, so this means this is -1. So whenever I had a counterclockwise epsilon, that is -1. If it was clockwise, like 2 3 1, so if I write 1 2 3, then 2 3 3 1, then it is clockwise, so it is 1. Remember, when writing these, you have to have 1 always here, 2 always here, 3 always here. Okay, so it was a brief review on Levi-Civita. If you need more detail, please see my previous tutorial. Okay, now here let me erase this quickly. Okay, now here summation is on I, j, and k, remember. So let me put this I, a the other side, so therefore it's epsilon I, j, k, a, I, b, j, c, k. And now let's write down the other one, this guy here. So this one is the left hand side. So now I'm going to write down the right hand side. So a cross b dot c. That means a cross b component I, ci, and summation is on I, equals, again using where is that, this equation, I get epsilon I, j, k, a, j, b, k, c, I. Now I'm going to use this property of epsilon. If I have a I, j, k, and if I replace, if I swap any two like neighbor indices, then I get a negative. That means, for example, epsilon I, k, j. So I swap two neighboring indices, k and j, and I got a negative. And this equals, if I bring k this side, k, I, j, so this is positive, so this equals this guy. And you can kind of solve some examples for yourself, like solve 1, 2, 3, and then you will see this is 132, because this is clockwise and this is counterclockwise. So now I'm going to replace these things, these indices, until I get this here. Okay, so here index of I is I, right? And since this I is repeated, there is summation on that. This we call a dummy index, so you can rename it to whatever you like. So you really can write I to be m and this I to be m. So there is no difference. You can expand it to understand it better, but there is really no difference if I use I or if I use m. It's a dummy index because it is repeated, because there is summation on it. Okay, so I'm going to rename I to let's say k. So I rename I to k, and then k to j, k to j, and j to so I'm going to make it I, like there. Okay, so it equals epsilon k I j a I b j c k. So like here, only epsilon is now a little bit different. I need to swap these indices until I get that. So now let me erase this part, and now you should always make sure that for example, this first index is summed with the c. So here c is indexed with first index of epsilon, so it is the same thing. So second index is summed with a, and here a is summed with second index. So, and third j with b, here third k with b, so they are equal. We just rename the indices. And now if I bring I this side, I get them negative, so I get minus I k j, and then I swap these two, and that would be I j k, right? So this means this is equal epsilon I j k a I b j c k, just like here. Where is that? Just like here. So we prove that these two are equal. Okay, now let's do this example quickly. And as always, my eraser is not large enough and it takes forever to erase these stuffs here. Okay, so let me first do this guy. So it's 2 I hat minus 4 k hat dot product I hat plus j hat plus k hat cross a minus 2 j hat minus 2 j hat plus k hat plus k hat. So, and I need to first, I always need to do the cross product first, otherwise it has no meaning. So I'm going to use some identities that I have covered in previous tutorial. So if you don't know these identities or formulas, please see my previous one. So I hat cross j hat equals k hat, so I get minus 2 k hat because I have a minus 2 here, and I hat cross k hat, so you can actually do this I, j and k, and if it is clockwise it is positive. For example, if I cross I by j, I cross j equals k hat and j cross k equals I hat, but if I go counterclockwise it is negative, so I hat cross k hat equals minus j hat, or j hat cross I hat equals minus k hat. Okay, and let's see, I hat cross k hat equals minus j hat, right? Minus j hat, and j hat cross j hat equals 0, j hat cross k hat equals I hat, k hat cross j hat, k hat cross j hat equals minus I hat. I have minus here plus 2 I hat, and that's all, right? So I have 3 I hat, and then this is dot by the other one. So it doesn't really matter if I dot from this side or the other side. Dot the place is not important. For k hat, and then equals k hat dot I hat is 0, k hat dot this guy is 1, so minus 2 times minus 4 equals 8, k hat dot k hat equals 1, so it's 1, j hat dot I hat 0, j hat dot k hat 0, and here I got, this is 3 I hat dot I hat equals 3 times 2 6, I hat dot I hat 1, and I hat dot k hat equals 0, so and it is 14. And you can do, this was the first one, and you can solve for this and you will see that you again will get 14. Thank you very much. Please remember to subscribe and also visit us at www.solvephysicsonline.com. See you next time. Bye.